Alright, so we're going to start out this week by looking at part of section 1.2 and 1.3. We've already done a little bit of each of these sections. So there's like a little bit left in 1.2 and a little bit in 1.3, and they kind of go good just to look at them together. So what we're going to be looking at is solving equations that have what we just did in the warm-up. Equations with parentheses. Now, when you have parentheses, what property do you always have to use? And it was in the directions on the warm-up.
We just did it.
Yep.
Distributive property.
Distributive property. All right. So this is just explaining what we're doing today. There's nothing you have to write down there. So basically, we're going to use distributive property. All right. On your notes, okay, we're going to start filling in, so they already have it.
They have this stuff in there.
So we'll go through it.
They may know it.
Yeah. So we'll fill it in.
They go back in their notes too. It's up to them.
Does anybody remember what word we used? It's like an acronym, 3 letters for solving equations. Not PEMDAS. That's for expressions. But that? SAM. So if you remember SAM tells you the steps, which I think we have really quick here. They're already in your notes. Okay, we did them last week.
Yes, these are the same steps.
So
We mean the week of academics.
yeah, last week of academics. But for those that weren't here, you might want to write these steps in on your guided notes right now. Okay, if you already have them, everyone else, it's up to you if you want to write them again. It's totally up to you. But we'll start with the S. What does that S stand for? Yusuf? Simplify. So under simplify, there's 2 things you have to do, and you kind of have to do them in a certain order. Savannah? Yep. Distribute first, and then combine like terms. This is the new one. Okay, we did not have any distributive last week. Okay, we did have combine like terms. I know we had that. But distributive property. Now, when you combine like terms, does anybody remember where you do it? We're not moving stuff from side to side yet. That's step 2 and 3. Yeah?
When they're on the same side.
Right, when they're on the same side. Okay, so one mistake that Mr. Roy and I see a lot is something like this. Let's say 2x plus 3x plus 1 equals 5x minus, 8. And I see some like terms on the left-hand side. Well, a lot of times people try to combine these. They say, oh, minus 3x, minus 3x. No. All right? The only time you do the opposite is when you're moving something from one side to the other. When it's on the same side, you just combine it the way it is. 2 plus 3, 5. You just add them up. Okay? Don't do the opposite unless you're moving something to the other side. Okay? Okay, so now after you've done step 1, you've simplified everything you can on each side. Now we got to start putting stuff on the same side. So what's the first math operation we use to do that? Yusuf? Adding and subtracting. So any adding or subtracting. Okay, here's a problem that would have some adding and subtracting. 2x plus 6 equals 18. Okay, there's something there that you would have to subtract from both sides if we were going to solve it. Does anybody see what you would subtract from both sides? Oh, Gigi? Do you see what you'd subtract from both sides? 6. Yeah. In that case, it was subtraction. Sometimes it might be addition. Okay, so adding and subtracting. And then, well, I didn't need to do that. But the last step is multiplying and dividing.
And guys, for that step 2, addition and subtraction, you may have to do it more than once. Like if you have variables on both sides, or if you have numbers on both sides.
Like in the warm-up.
Yeah, like the last example within the warm-up.
Yeah. Okay, so multiplication and division. Problem where you would have multiplication, or division would be something like this. That's a problem where you have to divide on each side. Anyone think they could give me a problem where you have to multiply on each side?
Because when you divide, you have a whole number. Think about when you have to multiply.
Chris?
Fractions.
Sure. Could you give me a problem?
3 over 4 times 5.
Times 5, so that would just make it 15 over 4.
Yeah.
Okay.
No, I mean divided by 5.
Divided by 5?
Yeah.
So if you divide that by 5, that would just make the bottom a 20.
Thank you.
Because it's like you'd be multiplying by 1/5. So let's put it back at 3/4, or if somebody wants to change it completely, we can. Yeah?
3/4 x equals 27.
Okay, so that's a good one to look at that does kind of fall in this. That's still a multiplication problem. Does anybody remember when you multiply both sides by in this case? Oh, I know it is multiplication. That's what I was looking for. But yeah, what do you multiply both sides by? Yeah, the reciprocal. Exactly. So that's one type of multiplication. In my head, I was kind of thinking of this type, where you have a letter on the top and a number on the bottom, and you have to multiply both sides by 4. But those are both multiplication. Yep, so perfect. Yep, nice job. Okay? Questions on that? So what we usually do, again, for people that are new, we just kind of go through some steps, and now we'll have you guys look at some examples. Okay, so this one's kind of similar to what we did, I think, the first problem in the warm-up, if you look at what you're distributing. So it says 12 equals negative, and then in parentheses 4x minus 8. Okay, I'm going to go back to the warm-up for 1 second, and I want to look at how this looks different than the problem in the warm-up. Okay, besides the exact numbers. Okay, the numbers might be different, but let's go back and look at it. How does that look different than what we're trying to do right now? Yeah, Mary?
There's no equal sign in the world.
There's no equal sign in the warm-up. There's an equal sign here. So whenever you see the equal sign, that means to solve. Okay, so let's go through our steps.
You guys, if you feel comfortable solving that the way it is, that's fine. And what else could you do? So it looks a little bit nicer. Anybody know? Let's think of most equations, right? Where's the equal sign? Usually. Yusuf?
At the end.
At the end, right? So what could you do? Not sure? Say it again?
You just do it like that.
You can do it like that too, that's fine. I said that. What else could you do to make it look a little bit similar to other problems? And it's flip it. So what would you do with that equals 12? Yeah, put it at the end. That's all. Just rewrite it so it looks a little bit nicer. That's all. And like Yusuf said, if you want to solve it like that, go ahead. That's fine too. You're not wrong.
Yeah, you can do it either way. So if we go through our steps, first thing is simplify. Natasha, what did we write down the first step under simplify was? Distribute. Do we have, well, how do you know if there's distributive property? What symbols will you see in the problem? Parentheses, yeah. So I see parentheses, so I know we have to distribute. Melanie, what do I have to distribute here?
The negative sign.
And what is that negative sign? It's really what number?
It's negative 1.
Yeah, it's really like -1. Right? So we're going to distribute that -1. Now, what did Mr. Royce say distributing a negative does? It really just takes the two things inside and does what to them?
Changes the sign.
It just changes the sign. The numbers don't change other than the sign. So 4x is going to become -4x. And Jacob, what about -8? If you change the sign, what would -8 become?
Positive.
Yeah, +8. Good. All right, so now we've done distributive property. I still got one more thing to check under simplified. That's combine like terms. Do I have any like terms there to combine on the same side? What do you think? How about Dylan?
No.
No, I've got, well, on the left, I only have a 12, so there's nothing at all to combine. On the right, I've got two things, but one of them has a letter and one of them doesn't. So I can't do anything with it. So now we're in our step 2. Catherine, what's step 2? Add and subtract. Do you see any adding or subtracting I would need to do here? What would I have to do? Yeah, subtract 8. You already have things with letters on the right. So things without letters are going on the left. And she said subtract 8 because we're trying to move it to the other side. Subtract 8. That's gone. And now on the right hand side, how about Laurel? What's 8 minus 8? 0. Gone. Okay. How about David? 12 minus 8?
4.
4 equals negative 4x. All right. Is there any more adding or subtracting here? How about Garrett? No? No more adding and subtracting. So we're in our last step. Okay. Haley, what's my last step?
Divide -4.
Yep. So it's the multiplication or division. Whenever we have a number in front, that's when we divide. And you said divide by what? Negative 4. Negative 4. The 4s and the negatives cross out. So on the right-hand side, Nicole, what's on the right-hand side now? Just x. And now once I figure out what to put there, I know the answer. So how about Alex, 4 divided by negative 4? Negative 1. Yep. And that's our answer. So x equals negative 1. Okay, any question on that? It's pretty straightforward. There's not really a lot of things that are tricky. It's not like you had the same variable on both sides where you gotta, sometimes it cancels out, you get like a true or a false. Distributive property is a little easier than that.
All right, so guys, all the ones that we do today, they're all going to have distributive property. Right, every one that we do. There may be combined like terms, there may not be combined like terms, but you're always going to have that. You're always going to have that simplified step. At least distributive property may be combined like terms. It depends. Give you guys a second to write that down. Dylan, what's the first thing I'm going to do here?
Well, simplify.
Simplify, that's simplify step. And what am I going to do in that simplify step? Remember, there's 2 things you could do.
You distribute.
Distribute, okay.
8 times 4.
Positive 8 times positive 4, I get.
Wait, what?
Positive 8 times positive 4.
Oh, there you go.
And then, what else am I going to distribute? I'm doing 8 again, right?
Yeah.
Times what?
3. Okay.
And what do I get? All you're going to do when you do that, don't get nervous because there's a k there. The k is just going to come down with it. What's 8 times 3? 20. Somebody help him out. 24. And then all I'm going to do is just bring that k down with it. That's it. 24k. That's going to be a plus sign. So once I distribute, that gets rid of the parentheses. They're gone. All right? Ellen, what are you going to say?
Then you have to put -7 equals 97.
Yeah, bring everything else down that you didn't use, which we did. All right, so we did distributive. All right, what else do we have here? How about, Bethany, what else do we have here? So we just distributed. we will minus on both sides. What is not there yet? So that next step, you'd be what were you gonna minus?
24.
Minus 24, okay, so next step, you're good. We just skipped a step, that's all. There's one more thing we can do there. So I'm gonna bring that, the plus 24K, I'm gonna bring that down. It equals 97. I'm gonna bring that down too because that next step, 24K. Alright, we will have to do something with that 24K, just not yet. What do I need to do before I do anything with that? Savannah?
I'm 32 is 30.
Yeah, I'm combining, right? Remember, don't do plus 7, or minus 32, right? When we're putting them together like that, we just call it combining like terms. We're not doing the opposite operation. Just do what the signs tell you to do. So 32 minus 7, what do I get, Savannah? 25. Okay. So like Bethany said in that last step, we are going to subtract. Alright? We're definitely going to subtract. Ellie, what number am I going to subtract?
24.
So subtract 24, what's the 24 have with it?
Okay.
A K, right? And what are you going to subtract from what number?
97.
97. So you're going to do minus 24K and minus 97. Everybody agree with that?
No.
Donovan says no. Why not, Donovan?
Because they're not like terms.
It's not like terms, right? That 97 would have to have a K to be able to do it, right? So Donovan, what are we going to subtract?
Negative 25.
Minus 25. Alright? That's going to cancel out. Alright? When I get to this, when I just subtracted it, when I get to that spot, I ask myself, which one thing, which is the 24K, the positive 24K, is not like the two others, the positive 25 and the positive 97. It's not like the two others because it has the variable with it, right? It has the K. So then you want it, the one thing that's not like the two others, you don't want to move that. The one thing that's not like the two others, don't move it. Leave it where it is. You'll deal with that after. I'm going to bring my 24K down. Again, 97, you can do it on your calculator, or you can just do 7 minus 5, 2, then 9 minus 2, 7. Alright? Brady, what's the last step? If you're not sure, you can look on your notes too.
Divide.
Want to divide by what number? Yusuf, what number is he going to divide by? 24. Why 24, Yusuf? It has a variable too, right? You always want to divide by, because you want to get the variable by itself, because that's what you're solving for. Always, when you get to that last step, divide by the number that has the variable attached. Alright? These are just going to cancel out. K equals, let's see if I can get, is it 3?
Well, yeah, but you have a variable now.
3. K equals 3. It doesn't say to check, so I'm done. Alright, so that had both steps of the simplify. It had the distributive property, which Dylan helped me with, and then Savannah helped me with the combining like terms, the 32 and the negative 7. So again, this is another step, right? But again, not too bad. Again, once you distribute, it's just like the stuff we did last week. Right? The only new part is the distributive. Now, as we have written here, again, another step, we may have 2 sets of parentheses to remove in order to solve. It might be on both sides. They might be on both sides of the equal sign. Both of them might be on the same side. It depends on how the problem's set up. So this one has equation, has parentheses, and they're both located on the same side. So we got the negative sign, then we got parentheses, 7p plus 3, then we got minus 3, parentheses, p plus 2 equals 61. So like I said, this one has parentheses on both sides, on one side of the equal sign. We may do one where there's parentheses on both sides, but in this case, it's only on one side. Alright? So in this problem, I can tell you right now, you're going to have to distribute, obviously, because you have the parentheses, and you're going to have to combine like terms. All right? Jake, what's the first thing we want to do?
Bring everything down.
But are we going to do, we're in that simplify step, right, buddy? So what are we going to do? What math operation do we have to use? Add, subtract, multiply, or divide? Not sure? Okay, buddy, I know it's Monday morning. We were up late watching the Pats last night. Savannah? Want to multiply, okay. Multiply what?
Yes.
-1.
-1, right? Again, if you know you have to distribute that negative, that's fine. Like Savannah said, if you want to put a 1 there, you can do that too. So I'm going to distribute the -1 to what? To what numbers? -1 to positive 7p, and -1 to what else? Positive 3. What's going to happen, Ellie, to the signs inside the parentheses?
They're gonna turn negative.
They're going to turn opposite, right? They're both positive, right? We're distributing in a negative. They're both going to change to negative. What's my first term going to be? Catherine, what's my first term going to be? I'm going to write to the right of that negative sign. 7p, right? I already took care of the negative. I'm just going to put 7p. What's going to come after the negative? Yeah. What's going to come after the second negative? 3. Just 3. If there was a p there, yes, but there's no p. I'm not distributing a p on the outside, so it just stays like that. This is done. Right? Once I distribute, again, the parentheses disappear. What's the next number? Alex, what's the next number I'm going to distribute? -3. We can still think of the same rules. I know there's a number greater than 1 attached to that negative now, but what's it going to do to the signs? What's it do to the signs of the terms inside the parentheses? Makes them what? Does it change them or keep them the same? Savannah? Changes them, right? So I got a positive p, that means it's going to be negative. I'm going to leave a little space so I can write my term. And I'm going to have another negative here. What's my first term going to be? Bethany, what's my first term going to be? I'm going to get a -6. That will be my second one.
Okay.
That's okay though, you got one of them. What's the first one going to be? How about Matt? So I got the 3 times p. -3p. I already put the negative, but if you're correct, Matt, nice job. Bring down the 61. David, what's next?
Combine like terms.
Give me one pair of like terms and tell me the sign of the two, please.
-7p, -3.
-7p, -3p. When I combine them, David, they're not positive, right? What's my answer?
-10p.
-10p. Some people make that mistake. I know they're both negative, but we're not multiplying, we're not dividing. Keep the sign, add the numbers together. That's all you need to do. Cancel, gone. Nathan, what's my other pair of like terms on the left-hand side of the equal sign?
-3,
-3. I'm going to box them out this time. Again, like David just told me, when you're combining negatives, they don't become positive. It's only when you multiply or divide. So what's my answer going to be?
-9.
-9. Good. 2 more steps, and I'm done. Melanie, what's the first of those 2 steps?
Add 9.
Add 9. Cancels out. 61 and plus 9 is what, Melanie? 70. On the left-hand side, what's left? Anybody? Eugene? -10. P. Last step is going to be what? How about Nigeli? What's my last step? Divide by what number? Negative 10. I always want to divide, when I get to that last step, I always want to divide by the number that has the variable attached. Now, Jelly, let me ask you this. Is my answer going to be positive or negative? Because we know this cancels out and gives me P. And I get a positive 70 divided by a negative 10. If they were both negative, I get a positive. One's negative, one's positive. Negative. If I'm doing a positive divided by a negative, or if it was the other way around, if this was a negative 70, that was a positive 10, it still works the same. So my answer is going to be what? Positive or negative? The only time when you're multiplying negatives, and you're going to get a positive outcome is when they're both negative. I don't care if the top one's negative or the bottom one's negative. It doesn't matter. If you have one negative, one positive, it comes out as a negative. Alright? Do you know what number, Jelly? Negative 1. Perfect. It doesn't say to check. I'm done. Again, that one, parentheses on the same side of equal sign. Again, combine like terms, get the variable by itself, divide. Pretty simple. Good with this? We can move on. Matt, you good with this? I think we got like 2 more left. We got 5 examples total, right, guys, on your notes? Okay. This one, this one's a little bit different than the other one. The one we just did, obviously the numbers are different. What about the setup? Look where the parentheses are. And think about where they were in the last one. How is this one different? Yusuf? Equal signs in the middle, meaning the last one we had parentheses on the same side of the equal sign. What about this one? The last one we did have parentheses on the same side. How about this one? They're where? Opposite sides of the equal sign. Right? If we go back and look at the last one, they're on the same side as my equal sign at the end. All right? This one, they're on either side. All right? So there may be combined like terms here. There may not be. I'm probably going to guess there's probably not going to be. Again, there's that negative sign outside the parentheses, which means I have to do what? Ellie? Distribute it in, right? Joe, when you have the negative on the outside, just the negative, what does it do to the signs inside the parentheses? Opposite, right? So what are my numbers going to be when I bring that negative in? Negative 4, positive y. That side is done. On the other side, when I distribute, what are my numbers and my letters going to become? Matt? 21 is the first one, right? 3 times positive 7 is 21. Plus 6y. Perfect. So distribute, after distribute comes what page? In our steps. Distribute, then combine like terms. Do we have like terms here? But we have this. I got positive y and positive 6y. They both have y's. Aren't they the same? What's the rule to combine like terms? They have to be where? Same sign, they're not, right? Okay, so now we get into moving stuff around. I don't care what we move first. You can move the variable, you can move the number, I don't care. Gigi, what do you want to move first?
Positive y.
I want to move the positive y, right? Because we got a positive y and a positive 6y. Move the smaller one. Like Yusuf said earlier, then you're not dealing with negatives if you move the smaller one. So what do I do, Gigi? Subtract y, subtract y. Just match them up. Variables go with variables, numbers go with numbers. Stuff I didn't use, I'm just going to bring it down. I didn't use the negative 4, I'm just going to bring it down. 21 I didn't use, I'll bring it down. Then I got positive 6 minus y. Gigi gives me what? Positive 5y. Good. Alright? Which, when I look at this, Brady, negative 4, positive 21, positive 5. Which one of those terms is not like the two others? No. One of these is this, the other two are these. Savannah? 5y, right? 5y is a what? Variable, right? The other two are just constants or numbers, all right? So the one thing that's not like the two others, you never want to touch that. You just want to leave it where it is, all right? So this 5y, we're not touching that. We want to get it by itself. So Brady, I want to get that 5y by itself. Nothing else. On that side of the equal sign, there should just be that 5y. What do I have to do? I just want 5y. Here's the equal sign, right here. What's on that side of the equal sign with the positive 5y? 21. Well, not divide, not yet. The next step we will, not this step. You got to get this over here. How do you do it? What kind of a 21 is it? Positive or negative?
Positive.
What's the opposite of positive? Subtract. Subtract what number? 21, right? I want to get it by itself. Where else am I going to subtract 21? From what number? I'll tell you one thing. It's not going to be from the 5y. We don't want to touch that. Negative 21 from negative 4, right? Same side. I'm sorry, same sign, and we're just combining the numbers. So what happens to the sign? Does it change?
Yeah.
It does. We're not multiplying. Stays the same.
Oh, yeah.
Stays negative. Add the numbers. 25. The stuff on this side I didn't use, I just bring it down. Now, like you said, Brady, we can divide. Divide by what number? Always divide by the number that has the variable attached. So what number has a variable attached? 5. Divide by 5. Negative divided by a positive. Yeah. I called that. We got a little trouble there. Why I call that? Negative, and the number is going to be what? 5. Again, the ones we do this week, guys, we're not going to have you check them. All right, we had you check them last week. Anything we do on the test on Friday, we're not going to have you check. Again, we just wanted to see last week, you understood how to evaluate stuff and plug it in. The stuff this week, you do not have to check. All right, one more. It says, if Jim's age is decreased by 9, and that difference is multiplied by 8, the result is 48. Find Jim's age. In this problem, what's the unknown? Well, what are we trying to find? Do we know how old he is, Yusuf?
Huh?
Do we know how old he is?
Oh, no.
No. So what do you want to put?
X.
X. There's Jim's age. X. What's the next? Dylan? Everybody sign. Just scan right here. What's the next word in there that might translate to something in algebra? Matt?
Difference.
Okay, even before that. Nicole? Okay, decreased. What's that mean, Nicole? Subtract. I'm just going to put a little minus here. I'm going to put a minus down there. What's the next thing? So, Jake, we just did Jim's age, X, decreased, minus. What's the next thing in that problem that might be important? Jim's age is decreased. That's what we stopped. What's the next thing in the problem, in the sentence that's important? Not yet. Look for a number.
9.
9. I'm just going to write 9. And that difference is multiplied by 8. The difference of what? Think about all the things we're doing, Mary. Think about every problem that we've done so far in this section has had what?
Oh.
Parentheses, right? So I'm going to put, Matt, were you going to say that, Chris?
Yeah.
I'm going to put parentheses. Outside the on this left-hand side, before the parentheses, is going to be what number? Yusuf? 8. Because the difference of this is multiplied by 8. Alright, so I've got this, I did the 9. The difference is multiplied by 8, I did that. What's the last thing I have to, actually I have to write two, I have to write two more things. I gotta write two more things. So I'm just gonna kinda, I know you guys probably wrote this down. All this, this, this. Everything up into that comma, I've used. I've plugged, I've used it, I've translated, I've done it. Done it?
Equals 48.
Equals 48, good man. Is means equal, and then just 48. Alright? So just like we've done, again, this one's only gonna have, once I distribute, we're only gonna have 2 steps. So when I distribute, Jake, when I distribute the 8 and the x, when I distribute that, what am I gonna get? This is saying 8 times x. When I do 8 times x, what do I get? Nicole just helped you out. Was that you, Nicole, that said that? 8x? 8x. So whenever you have, Jake, whenever you have just a single variable inside the parentheses and a number on the outside, just put the two of them together, smush them together, and get 8x. What's the last thing when I multiply and I distribute? What's the other term? What's the other term gonna be? What number? It won't have a variable this time. What number is it gonna be? Matt, what do you think? I did 8 times x, 8x. I'm gonna do 8 times what?
9.
Careful.
Negative 9.
Negative 9. What do I get?
Negative 72.
Negative 72. Good man. 2 more steps. Nathan, what am I gonna do now?
Add 22 from each side.
That's a 72, buddy. My handwriting's really bad. I'm sorry. Add 72. Add 72. This is gonna be 120. All right. Last step is gonna be what? Chris, what's the last step?
Divide.
Divide by what number?
8.
8, because it has a variable attached, right? If I do my thing here, 120 divided by 8. Who we just solved for? Ellie?
Jim's age.
So x equals 15. Jim is 15 years old. So again, we may give you one on a test on Friday. That's a word problem, but that uses distributive problem. You know, we want the homework like that too. All right. So this was section 1.2, part 2, and 1.3, part 2. So a lot of the majority of the examples you wrote down today, you'll be putting on your reference sheet on Thursday. And like I did last week, guys, I'm going to try to get that reference sheet up a little bit earlier. Hopefully by Wednesday afternoon, you guys can get on there and start copying down some of your examples. All right. Homework tonight, I think there's 8 problems total. Again, very similar to what we did in class today. Leave that up, so there are some extra examples. I want you guys to practice those, so leave your notes out.
Alright.
Like I told you guys at the beginning of class, this is the last week before progress reports. So we had that short 3-day week. You guys first came into academics, really didn't do an awful lot. There was no test, no homework or anything. Last academic week we had homework, the test, all that stuff will be used for your progress report. And then anything we do this week, including the test on Friday, will be used for your grade. Some of you guys that just transferred in, Mr. Hager and I will get the stuff from the teacher you had before. We'll use the stuff from last academic week and then the new stuff from this week. Get a copy of your grade. All right. Like Mr. Hager said, review day on Thursday/MCAS. So first half of the class, we'll do the MCAS problem. Second half of the class, we'll do review. Guys, there'll probably be some bonus points at stake on the test on Friday when we do the review. We get a certain amount of questions right in the review. We'll give you bonus points on the test on Friday. And like we said, test on Friday. You'll hopefully, like I said, I'll have the reference sheet hopefully up by Wednesday night, so you guys can start on that. And then you'll have the test review for homework